Good morning, everybody, and thanks the organizer for inviting me to this webinar. Today, I will share with you the topic on using computational flow dynamics to investigate outbreak investigation. Hi, I'm Professor Dr. Victor Ho from the Department of Social Palliative Medicine, Faculty of Medicine, University of Malaya. Computational flow dynamics is a powerful branch of fluid dynamics that uses numerical and analysis and data structure to solve complex fluid flow problems. This is a picture of a F1 car with the lines that shows how the fluid dynamics flow through the F1 car. The application of CFD is through aerospace and aerodynamics, automotive engineering, environmental engineering, industrial design, and biological engineering. These are their uses. Today we are going to discuss about the use of computational flow analysis in environmental engineering, where it is used for modeling weather patterns, predicting pollutant dispersion, and designing efficient ventilation system. The benefit of CFD is the accelerated decision making, reduced developmental and time costs, enhanced innovation, and sustainable testing. But it also has its challenges. The main challenge is that it needs high computational demand, which means that it needs a lot of computational power to come out with the diagram or the flow dynamics. And of course, with that also that you need the expertise to actually implement CFD effectively and efficiently. Today, I'm going to discuss with you a case study of using computational flow dynamics to investigate outbreak of airborne pathogens. So we start with outbreak investigation. It's important to note that this happened during the COVID-19 pandemic back in 2021, which is almost the start of the COVID-19 pandemic. The index case was a 75-year-old man who was in the oncology ward. On day one, he was admitted from emergency department with a chief complaint of lethargy and cough. The healthcare worker placed the old man in an open ward. An open ward is the ward where there's many patients within the same ward. And it is not a COVID ward. It's an oncology ward. So there's many oncology patients within that ward. Had a dry cough, otherwise comfortable under room air with SpO2 of 98% on room air. He was put under isolation. We tested that with COVID-19, and on day 4, he was found to be COVID-19 positive. So, what should we do? We started with the outbreak investigation. There was 48 individuals were in contact with the index case. 8 individuals contracted COVID-19, out of which 4 were among the healthcare worker and 4 were among the patients. There were 42 healthcare workers who had been exposed and 6 patients exposed during the index case stay in the ward. It is important to note that during the COVID-19 pandemic, all healthcare workers need to complete an online COVID-19 risk assessment form. This is a requirement for any healthcare worker who has been found to be exposed to a COVID-19 patient, either at work, which is in the hospital, or at home, or anywhere else. They need to complete the online COVID-19 risk assessment form. The idea is that for us to be able to risk categorize each of the healthcare worker to ensure that the services within the hospitals are continued. We would usually, what happen is that a healthcare worker with low risk would be continue to work. So this is the investigation form. It's an online form. So the online form, then you just complete the information inside the form, and after that, they will give you a result. And the result consists of the risk level and also instruction on what you need to do. The level of risk in the outbreak form can be low, medium, or high, and depending on whether the workers how the workers was exposed to a COVID-19 patient, and also it also include whether there's symptom or no symptom of respiratory symptom like cough, running nose, and similar symptom. So 8 individuals contracted COVID-19. 4 were among the patient. Of course, because the patients are in the open ward, they are all high risk, and that is what we know. But the other 4 who is healthcare worker have completed the risk assessment form and found to be low risk, as they are wearing the appropriate PPE when attending to the patient. So, how did the healthcare worker contracted the COVID-19? That is what we need to do or investigate to find out. So, what we did is we conducted what we call a walk-through survey. And this is initiated to identify the potential source of the infection. A walk-through survey is where we, as an occupational doctor, go to the ward or go to any workplace to see the normal work and to see where the potential source of infection, of contaminant, of hazard is there. So we conducted a walkthrough survey in the ward where the patient was admitted. This is the floor plan of the ward. The yellow box indicate the open ward with 5 beds and a bath. Right. The X marks the spot where the patient was sleeping, and the other 4 beds is where the 4 other patients who contracted COVID-19 was sleeping. You might want to ask me, there is only 5 beds, but you mentioned 6 patients. This is because patient discharged and readmit, and new patient are admitted. So the patient was discharged. But they were still considered a contact because he was in the cubicle when the index case was there. So there is a computer workstation at the corner of the room where the healthcare worker needs to perform their clerical work, which means that they need to, because UMMC is a paperless hospital where medical records are all electronics or electronic medical records, the healthcare worker needs to upload or enter the medical record into the computer once they have completed the clocking of the patient. This shows the 5 supply van, which is from S1 to S5, and R1 is the return van. Alright, so what is that? Let me explain to you what supply and return means in the context of ventilation, especially in a room. The picture you see here is an ICU with a return and a supply van. You can see on top, that is the return van and the supply van. The return van is usually have horizontal fins. In this picture, you will see a typical centralized air conditioning and how the air flows within the centralized air conditioning. Outdoor air intake, it is cooled or conditioned, and then it circulates within the room, and after the warm air, it instantly returns to the return vent. So the blue downward arrow shows the supply vent, and the blue and red upward arrow shows the return vent. This is how normal air flows within a room, which is not a laminar flow room. In this room, in this picture, you will see another ICU room, which is a little bit different from the one you see just now. The difference is that the supply and the return are located at different level. The supply vent is located on the ceiling, while the return vent is located next to the patient or lower down. This is because hot air will rise and cold air sink because of the weight of the cold air compared to the hot air. This is to reduce circulation within the room, and this is what we call a laminar flow, where the air flows from the supply to the return with minimum circulation within the room, and this actually reduces the chances of contamination. But today we are not talking about this. Today we are looking at a normal room, which is the one that you see previously. But just to highlight what does a laminar flow means, this picture shows an operating theatre with a laminar flow. Outdoor air is taken in, is cooled, and then it is basically there is a return vent at the bottom of the room, and also another smaller return vent at the top of the room. So the air actually flows in a laminar pattern, and there is minimum circulation within the room to minimize contamination. Let's just move back to the case, since now you understand what I'm talking about when I refer to supply vent and return vent. So when we completed the walkthrough survey, we found that the airflow in the ward was suspected to be contributing to the cause of the outbreak. By looking at it, we suspect there is an issue. This is how it looks. Alright, if you look at it, the supply is on one side, the return is just below or above the where the computer station is being located. So the question we ask is that, is there a potential for the air to flow from the area of the patient to the computer workstation? How can we answer this question? To answer this question, we decided to conduct a CFD with the assistance of the University Malaya Mechanical Engineering Department. So the process of creating a CFD is you need to have a model, create a model of the space to analyze using a 3D design software, something like SolidWorks, export the model into iGELTS file, read it from analysis software, and set the boundaries condition for the inlet and outlet, and then perform the calculation analysis. This is what we have done, or not me, but the engineering team have done. So what we did was, we went to the room from our side. Our safety engineers and safety technician went to the open ward and measure the size of the room, measures the height of the area, and then collected airflow velocity in 4 directions from each of the vent, and then average it out. So this is how the airflow is conducted in the ward. The engineer is actually holding a probe that contains a sensor at the tip of the probe to detect how fast the air is flowing, and she's reading it from her handheld device. So this is a handheld airflow monitor. So for this type of airflow monitor, you need to collect from 4 directions, which then average it out to give a average of how the air flows from the supply vent and also from the return vent. This is a measurement that we recorded. We have 5 supply vent and 1 return vent, and air velocity is as indicated, the average air velocity as indicated in the table as shown. So we put in all those information into the computer, and then we run computation flow dynamics, and then you can see the diagram as is shown below. If you observe how the air flows, the small blue bubbles, you will see that the air actually is flowing from the patient area towards the computer workstation. So then that's how we concluded that the outbreak, the 4 healthcare workers who has been infected by COVID-19 is due to air circulation. The CFD shows that the air flows from the patient area to computer workstation, which is a possible mode of transmission. The presentation demonstrates the use case of CFD, computation flow dynamics, in an outbreak investigation. During COVID-19 pandemic, it is important to ensure the safety and health procedures implemented are adequate for the safety and health of the healthcare worker. There is a low-risk individual should not get COVID-19. We must assure that. We must assure all healthcare workers that, because then they will be confident enough to continue to work in the ward. The investigation highlights that the procedure for the personal protective equipment that we give was adequate. Other uses of CFD in hospital setting, that what we have done, what we have used is to actually use the CFD to design a new ward which is an isolation ward. So the diagram actually shows the supply and the return. If the supply and the return is both on the ceiling, as we mentioned just now in one of our diagram or in a video that we show, the air would not return back into the return, and it will stay around the room, which basically is potential for circulation and contamination. So the engineers decided to move the return down next to the patient, near the patient head, so that the air actually can flow from the supply to the patient and then return back. So the chances of contamination is lower. This is how the diagram actually looks. All right, the supply and the return, and you can see that the air actually flows back much more easily. Of course, you say that this one there's much more airflow. Yes, it's much more airflow, but it actually flows back, and it does not accumulate or stay within the zone. So what can I do at my workplace? What can you do at your workplace? The important thing you need to understand is you need to understand your hazard. You need to know what personal protective equipment to use, and you need to follow all the instruction that is given to you by your occupational safety and health coordinator or occupational safety and health officer. Thank you very much, and I would open for discussion or any question. Thank you.